Let's look at IPv4 network subnetting. Why do we need subnetting? The first reason is reduce broadcast traffic by creating smaller broadcast domain, so that improve network performance. Second reason is create a different policy to secure each subnet. The subnetting is the process of segmenting a network into multiple smaller network spaces called subnetworks or subnets. Originally, IPv4 network was designed with three user classes. Class A used the first octet representing network portion. The rest of the three octets representing host ID. A single Class A network provides over 16 million IP addresses. Class B is using the first two octets for network portion, the second half, two octets representing host ID. So each Class B network provides over 65,000 IP addresses. Is still very big. Class C is the smallest network. It uses 3 octets as network ID and only 1 octet for the host portion. So each Class C network provides 256 IP addresses. That's the class-based IP address design. In industry, we actually use classless. We can create the network size as we need. Subnetting is like divide a pizza. You got a network that may be too big, like a Class C that has 256 IP addresses. But actually, you need to have 5 smaller networks. Each network only needs 30 users. So that way we can divide the given Class C network into 8 smaller networks, just like divide a pizza to 8 pieces. And the basic subnetting is divide a large network into multiple smaller equal-sized subnetworks. That's the basic subnetting. So let's look at how do we do it. Before we do the subnetting, we need to quickly review fundamental skills. How to convert a binary to decimal. We know the IP address is 32 bits binary. That is represented using a dotted decimal. 4 decimal numbers separated by dot. So each decimal number is called an octet. Each octet is represented by 8 bits binary. So we need to be able to convert any octet to 8 bits binary. Vice versa, convert 8 bits binary back to the dotted decimal number. Like, for example, here, dot 224, representing 8 bits binary. We use the place value to convert 8-bit binary to a decimal number. So you can see for a given 8-bit binary, like here, then each binary bit position has a place value. It starts from the least binary bits that has place value of 1. The next binary bit on the left has place value of 2, then 4, then 8. Each binary bit place value is doubled as we move towards left to the next binary bit, like 16. Next is 32. The next bit on the left is 64. Then the highest place value for 8-bit binary is 128. So use this binary value, we can easily convert this given binary 111.000.00 to a decimal. We simply take each binary bit times its place value. Here, the highest binary bits is 1 times its place value 128 plus the next binary 1 times 64 plus the third one 1 times 32. That's all. The rest of the binary bits are 0. No contribution to the decimal number. So add them up. We got the decimal number for this 8-bit binary, that is 224. We will need this conversion technique to do the subnetting. We know any given IP network that has a network portion and a host portion. If we got an IP network 192.168.5.0/24 that has 250 IP addresses. We want to subnet this given class C network and create 2 smaller subnetworks. So based on the given subnet mask, we know the first 3 octets are network portion. The last octet is the host portion. So we write the host portion into 8 bits binary so that we can borrow bits from the host portion. Borrow 1 bit from the host portion. The borrowed bits always start from the leftmost bit. Add this bit to the network portion. So once we borrowed that bit, the network portion extended from original 24 to 25 bits. That gives us a subnet mask /25 for this newly created subnetworks. And only 7 bits left for the host portion. After borrowing 1 bit, we create 2 subnets with the same subnet mask /25. Now, when the borrowed bits take the binary value 0, that's the subnet 0 we created. You can see the borrowed bits take the value of 0. The remaining host bits, starting from all 0, going up to the highest host bits value to 7 binary ones. That give us the IP range for this subnet 0. The range is 5.0 all the way up to 5.127. Subnet mask /25. And write the subnet mask in a format that's 255.255.255.128. That is the subnet 0. When the borrowed bits take binary 1, then the following 7 host bits start over again from all 0. That gives us the decimal number 128. When the 7 host bits goes up to the highest value all once, that is 225. So subnet 1 provide IP range from 5.128 up to 5.255. Same subnet mask. This can be viewed using this binary chart. We borrowed the bits from the last octet, that's /25. So this binary bits we borrowed. When this borrowed bits take the value 0, that gives us the first half of the IP range. That starts from 0.0000000. That's this starting IP 5.0. Then going up to 0 1111111. That's this value. That is the first half of the given class C. When we borrow the binary bits from /25 position, when the borrowed bits take the value of 0, we got the first half. Then when we change the borrowed bits to binary 1, that gives us the second half. That's the 1 starting over again from the host bits all 0. That's 1 0 0 0 0 0 0 0. That's 128. Going up all the way to 1 1 1 1 1 1 1 1. That is 255. So that chart gives you clear binary pattern. Visualize the picture. So when you borrow 1 bit, you create 2 subnets. Each subnet is half of the given class C IP range. Look at an example. We want to subnet the given network 192.1.1.0/24 and create 5 smaller subnetworks for this network diagram. Okay, this is the given class C network. And we write the last octet into 8 bits binary so that we can subnet from there. First, we need to determine how many bits to borrow. The number of subnets required can be calculated using the formula 2 to the power of bits borrowed. The more bits we borrow, the more subnetworks we can create. So to create 5 subnetworks, we need to borrow 3 bits. Use this formula 2 to the power of 3 give us 8 subnetworks. Once we borrowed 3 bits, our network portion extended from original /24 plus 3. The new subnet mask for the subnets would be /27. Write /27 into a formal subnet mask that is 255.255.255.224. The IP address available per subnet equal to 2 to the power of the bits remaining in the host portion. So we have how many host bits? Original 8 host bits, borrowed 3, so minus 3, 5 host bits left. 2 to the power of 5 give us 32 IP addresses per subnet. We must reserve the first IP as a network for each subnet, and the last IP is the broadcast. So the actual usable IP address is 32 minus 2, 30 usable IPs. The first IP in each subnet is network address, and the last IP address in each subnet is broadcast address. Those 2 special IP addresses must be reserved. They are not usable. Now, let's look at the subnet 0. When we take the lowest value for the 3 borrowed bits, 0, 0, 0, that gives us subnet 0. So the 3 borrowed bits increase that create a new subnet. So we start from lowest subnet value, 0, 0, 0. And the host portion starts from lowest value, all zeros, so 5, 0. This is 1.0. This is network address. When the host value add 1, first usable, going up to the highest IP address in subnet 0, that is when the 5 host bits take the highest value 11111. That is the broadcast. The first IP address is always network. All the IPs between network and the broadcast are usable IPs. Here is 1.1 all the way up to 1.30 are usable IP address for subnet 0. So then we increase the 3 borrowed bits one at a time. That create the following subnet. Let's look at subnet 0 we already created. Then we increase the borrowed subnet bits by 1. That's 001. That create subnet 1. And the 5 host bits start over again from all 0. That is the subnet network address. Convert 001, 00000 back to decimal, that is 32. So 1.32 is the network address for subnet 1. When the 5 host bits going up to the highest value, binary all ones, that give us the broadcast. Convert this highest binary value to decimal, that is 1.63. Then we increase the 3 subnet bits by 1. That's 010. That is subnet 2. And the same host portion start over again from all 0. Then give us the equivalent decimal number is 64. Is the network address for subnet 2. And when the 5 host bits goes up to the highest value all ones, that give us equivalent decimal number 95. That is the broadcast. The same, we increase the subnet bits again to 011. That's subnet 3. And all the way up to the highest subnet ID would be the 3 bits. Take the highest value 111. That give us the last subnet, subnet 7. The host portion start over again from all 0. That is 224. Going up to all ones, that is 255. So the subnet 7 IP range is from 1.224 all the way up to 1.255. And the usable IP address is from 1.225 to 1.254. The first one, 1.224, is network address for subnet 7. 1.255 is the broadcast for subnet 7. So those are the 8 subnetworks we created by borrowing 3 bits from original host portion. And all those subnet numbers are showing in this chart. Assign those subnetworks. N1 use subnet 0. N2 use subnet 1. N3 subnet 2. N4 subnet 3. And N5 subnet 7. We use the last subnet for the connections between headquarters and the branch. Thanks for watching. If you found this video useful, please click like and subscribe.